Hello everyone, thank you very much for signing in and watching my live stream. I'm Mr. Matt and this is Dr. Tot. Dr. Tot, you want a cookie? Kinda? Okay. Welcome to Geometry. We're going to continue our review for the Semester A midterm exam. This is part 3. Remember that you want to use these live streams in addition to practice test 1, which will be listed in the description, as diagnostic tools to identify specific subtopics that you need to improve upon before the exam. If you find anything in this video that's a little bit confusing and you want more practice, I will be putting out independent practice sets and quick drill sets that will supplement this material. The independent practice sets will be a larger document that will contain multiple problems throughout levels, varying levels of difficulty for you to get a maximum exposure to all the subtopics. The quick drill sets A and B will be difficult problems and emphasizing word and real-life scenario problems whenever possible. Let me go ahead and share my screen with you. Remember that this is a live stream, so there is a little bit of a delay with the iPad, but I'll mitigate that as much as possible. Today we're going to take a look at some geometric proofs that involve the angle addition postulate, properties of equality, as well as using the definition of a right angle. So this document will be available on Certified Learning Center's website. The link will be listed in the description below. Just make sure that you're looking for the document that has the reference number 2049-12. I know that's a really odd number, but there's a lot of documents listed there. And let me scroll down, it's a little bit of delay. And I'm circling that there. So 2049-12. If you have any questions at any point, feel free to post them in the comments below, or my social media accounts are listed in the description. You can always ask me any question or reach out if you have any recommendations for a video and whatnot. But otherwise, let's just go ahead and look at the first example, problem number 1. So we're going to address these in terms of geometric proofs. Remember that we have 2 columns in a geometric proof. We have the statement and then the reason. So you're going to start with your given information, and which is that the measure of angle ABC is 120 degrees. That point D is on the interior of angle ABC. That angle ABD is 2x degrees. And angle DBC is 3x degrees. And I want you to create a geometric 2-column proof that proves the measure of angle DBC is 72 degrees. So I'm going to give you 4 minutes. After 1 minute, I'll start to solve to give you some hints. I'll also keep track of the time in the upper left-hand corner, and I'll update it per minute. Okay, so first of all, it might be handy to draw out a diagram because usually you would be given a diagram. I made this a little bit trickier without one. But if the measure of angle ABC is 120 degrees, now again, remember there's a little bit of a delay here with the iPad, but let me go ahead and draw this diagram out. So if ABC is 120 degrees, then it might look something like this. And they tell us that D is on the interior of ABC. So I'm going to draw this diagram in the upper right-hand corner. And what we can tell is that the total angle of ABC is now bisected, I shouldn't say bisected because that means split equally, but separated into two smaller angles. And we know that one angle, ABD, is 2x degrees, and the other angle, DBC, is 3x degrees. Now what we can do is, if we know that the whole thing is 120, we know that from the angle addition postulate that the two smaller angles added together have to equal the larger angle in total. So we start with our given information. The measure of angle ABC is equal to 120 degrees. The measure of angle, and that's given. The measure of angle ABD is equal to 2x degrees. That's given. And then and number 3, the measure of angle DBC is equal to 3x degrees. That's also given. From the angle addition postulate, we can say that the measure of angle ABD plus the measure of angle DBC must equal the measure of angle ABC. So the two smaller angles added together have to equal the larger angle, and so the measure of the larger angle has to equal the sum of the two smaller angles. Now we can substitute in the expressions that are given to represent the measures of angle ABD and the measure of angle DBC and the actual measure of angle ABC that's given. So we can say that 2x plus 3x must be equal to 120 degrees. Simplifying, 2x plus 3x is equal to 5x. Dividing by 5 using the division property of equality, we'll find that x is equal to 18. Now that doesn't mean that the angle is equal to 18. That means the common multiple of x between the two expressions of 2x and 3x is 18. So now we need to use the substitution property of equality to substitute in 18 for x into the expression that represents the measure of angle DBC. So 3x can be evaluated as 3 times 18, which is indeed 72 degrees. If you have any questions, then please let me know. Otherwise, let's take a look at question number 2. So I'd like you to create a 2-column proof to justify the following statements using the given information. So given, angle ABC is a right angle. Point D is on the interior of angle ABC. Angle ABD is 4x degrees, and angle BDC is x degrees. I'd like you to prove that the measure of angle ABD is 72 degrees. I'm going to give you 4 minutes, and after 1 minute, I'll start to solve. Okay, so going through number 2, if we start with the given information, angle ABC is a right angle. Angle ABD is 4x degrees, and angle DBC is x degrees. Those are all given in the problem. Now, I went ahead and used the angle addition postulate. If you first defined a right angle to be 90 degrees, that's perfectly fine. But we know that the measure of the two smaller angles has to equal the measure of the larger angle. So the measure of ABD plus the measure of angle DBC has to equal the measure of ABC due to the angle addition postulate. Then we can define the measure of ABC to be equal to 90 degrees as the definition of a right angle tells us. And then we can use the substitution property of equality to substitute in the expressions that represent the two smaller angles, 4x and x, and the overall angle of 90 degrees. So 4x plus x is equal to 90. We can say now through simplification that 5x is equal to 90 because 4x plus x is equal to 5x. Dividing by 5, we're going to find x is equal to 18. And then finally, using the substitution property of equality, we can substitute in 18 for x as the common multiple in the expression 4x that represents the measure of angle ABD. So 4 times 18 is 72, and that proves the statement that they asked us to prove. If you have any questions, then please let me know as always. Otherwise, let's look at question number 3. So create a 2-column proof to justify the following statements using the given information. So given, angle ABC is a right angle. Point D is on the interior of angle ABC. Angle ABD is 4x degrees. And angle DBC is 2x degrees. And I'd like you to prove that the measure of angle I'm getting all tongue-tied, I'm sorry. Please prove that the measure of angle DBC is 30 degrees. I'll give you 4 minutes, and then I'll update it per minute, and after a minute I'll start to solve. Okay, so for number 3, we have the given information that angle ABC is a right angle, that angle ABD is 4x degrees, and angle DBC is 2x degrees. That's all given in the information. From there, we can define the right angle to be equal to 90 degrees, so the measure of angle ABC must equal 90 due to the definition of a right angle. We also know that the sum of the two smaller angles that make up the 90-degree angle have to be equal to the 90-degree angle. So if we take the measure of angle ABD plus the measure of angle DBC, that must equal the measure of angle ABC due to the angle addition postulate. Now, substituting in the expressions and the actual degree measure for the different angles. So the expressions 4x and 2x represent the measures of angle ABD and angle DBC, respectively. So we get 4x plus 2x is equal to the measure of ABC, which is 90. Now, simplifying, we'll get 6x is equal to 90. Using the division property of equality, we'll divide by 6 on both sides and get x is equal to 15. Using the substitution property of equality, we know that x is the common multiple. 15 is equal to x. So in the expression 2x that represents the measure of angle DBC, we can evaluate that measure to be equal to 2 times 15, which is 30. And that proves the statement that they asked us to prove, which is the answer. So if you have any questions, then please let me know. Otherwise, let's move on to number 4. Number 4 is going to be similar to the others, but remember that a straight line consists of a total degree measure of 180 degrees. So anytime that there's a straight line, you will have 180 total degrees, and any angles that make up that straight line are supplementary to each other. So supplementary means they add together to 180. Complementary means they're added together to get to be 90. So we have the given information. ABC is a straight line, and point D is on the interior of angle ABC. Angle ABD is 7x degrees, and angle DBC is 5x degrees. I'd like you to prove that the measure of angle ABD is 105 degrees. I'll give you 4 minutes, and after 1 minute, I'll start to solve. Okay, so for number 4, we're given that ABC is a straight line. We're given that ABD is 7x degrees and DBC is 5x degrees. So those are all the beginning given statements. We know that that angle ABC has to be equal to 180 degrees because that's the definition of a straight line. We know that the two smaller angles summed together have to give us the larger angle, so the measure of the two smaller angles added together has to give us the measure of the larger angle. That's due to the angle addition postulate. If we then substitute in the expressions that represent the measures of those two smaller angles and substitute in the exact measure of the straight line, which is 180 degrees, we get 7x plus 5x is equal to 180. Simplifying, 7x plus 5x is 12x. Using the division property of equality, we can divide by 12 on both sides to find that x is equal to 15. And then using the substitution property of equality, we can substitute 15 as the common multiple into the expression that represents the angle measure of ABD, which is 7x. 7 times 15 is 105 degrees. So we've proven the statement that they asked us to prove. If you have any questions, please let me know. Otherwise, let's look at question number 5. Question 5 asks, create a 2-column proof to justify the following statements using the given information. Given that ABC is a straight line, point D is on the interior of angle ABC, angle ABD is 6x degrees, and angle DBC is 2x degrees. I'll give you 4 minutes, and after 1 minute, I'll start to solve. Okay, so for number 5, we know that from the information that's given, angle ABC is a straight line, the measure of ABD is 6x degrees, and the measure of DBC is 2x degrees. So those are all my beginning fundamental given statements. From there, we can define the straight line as 180 degrees, so the measure of angle ABC is equal to 180 due to the definition of a straight line. We know that the two smaller angles have to sum together to make up the larger angle, so the measures of the two smaller angles have to sum up to equal the measure of the larger angle. The measure, therefore, of ABD plus the measure of angle DBC must equal the measure of ABC. Due to the angle addition postulate, if we substitute in the expressions that represent those angles, then 6x plus 2x must be equal to 180 due to the substitution property of equality. If we simplify, 6x plus 2x is 8x, so 8x is equal to 180 due to simplification. Dividing by 8 on both sides, we'll find that x is equal to 22.5. That's just due to that's due to the division property of equality. And then finally, taking that common multiple of 22.5 and substituting it into the expression that represents the angle that we're interested in, ABD. They told us that ABD is equal to 6x degrees, so 6 times 22.5 is 135 degrees. So we've just proven the statement that they've asked us to prove, which is that angle ABD is 135 degrees. If you have any questions, then please let me know. Otherwise, let's go to question number 6. This will be the last question for today and bring us up to the end of class. So again, I'd like you to create a 2-column proof to justify the following statements using the given information. So we know that ABC is a straight line. We know that point D is on the interior of angle ABC. We know that angle ABD is 17x degrees. And we know that angle DBC is 7x degrees. I'd like you to prove that the measure of angle ABD is 127.5 degrees. I'll give you 4 minutes, and after 1 minute, I'll start to solve. Okay, so for number 6, we have given information that ABC is a straight line, that the measure of ABD is 17x degrees, and that the measure of DBC is 7x degrees. So given that, we know that the measure of angle ABC has to equal 180 degrees due to the definition of a straight line. We know that the smaller two angles added together comprise the larger angle, so the measures of the smaller two angles added together has to equal the measure of the overall larger angle. So we know that the measure of angle ABD plus the measure of angle DBC must equal the measure of ABC because of the angle addition postulate. We can now substitute in the expressions that represent these individual angle measures. So 17x plus 7x must equal the 180 degrees in the straight line. Simplifying, 17x plus 7x is going to be 24x. Using the division property of equality, or divide, in other words, that's a fancy word for dividing on both sides by 24. 180 divided by 24 is 7.5. Using 7.5 as the common multiple, and using the substitution property to substitute it into the expression that represents the measure of angle ABD, which is 17x, we're going to have 17 times 7.5, which is 127.5 degrees. So we have indeed proven what they asked us to. If you have any questions at all on anything that we've done, please don't hesitate to ask in either the comment section or to contact me on any of my social media accounts. Remember that if you had any trouble, I will be putting out independent practice sets and quick drill sets that supplement this material. So you can look for that all in the description. If it isn't out yet, it will be soon. But otherwise, if you find these videos helpful, please like, subscribe, and share with your friends. I hope you all have a wonderful night. And Dr. Tot, do you want to say goodbye to everybody? Get a cookie? Come on, let's say goodbye. Come on. I know, it's very hard for you, huh? Say bye. Can you say bye? It's kind of bye. Is it a little better? Bye? Okay. All right, that's good. All right, thank you guys very much for watching. I hope you have a wonderful night, and I'll talk to you all tomorrow.